So in this video, we're going to look at the units of measurement. And we're doing this because when we collect data as scientists, there's almost always some unit attached to the data that we've collected. So here are some common different types of observations we could collect. We could collect a weight, a length, or a volume, for example. These values in table 1.1 from your book are common English system values. So it's what we're used to in the States. It's not used by pretty much anybody else or the scientific community, but we are used to it. The reason it's not is because it's kind of difficult to go back and forth from one to the other. So the conversion factors are sort of tedious and they don't really have a systematic way to go in between them. That said, we're familiar with these, so I'm just going to cover them very quickly. When we talk about our weight, we would talk about how much we weigh in pounds. If something is very small, we might talk about how many ounces it is. If it's large, we talk about it in terms of tons. So 1 ton is equal to 2,000 pounds. You often hear tons described when you talk about the towing capacity of a truck, for example. When we think about length in the States, we have, on road signs, is this many miles to the next thing. We talk about feet when we talk about how tall we are. So as humans, I'm 5'11" inches. So that's a familiar unit for us. With volume, we think about gallons. You can buy a gallon of milk. We think about quarts when we think about a lower thing. But like I said, we don't use these much in terms of scientific measurements because they are difficult to convert back and forth between. And what we're going to do a little bit later in the chapter is convert units, which we need to be able to do. So these are common to us. We use these in the States, but they're not used pretty much anywhere else or in the science community. What we do use in the scientific community is the metric system. And part of the reason that we use it is because it is systematic, and so it's easy to transfer from one to another. So if we kind of look here in the middle, we have the bigger numbers on the top and the smaller numbers on the bottom. So you guys are familiar with like centimeters, for example. Remember back in grade school when we would have a ruler, we'd measure something in centimeters. So a centimeter is 10 to the negative 2 meters, okay? So a meter would be kind of in the middle there. A decimeter is 0.1 meters, okay? And then we can get smaller and smaller. So we go to a millimeter, a micrometer, and a nanometer. So a nanometer down here at the bottom here is really small. That's 10 to the negative 9 meters. So when we talk about chemistry, you'll often hear about nanochemistry, and that's working on that very small molecular scale. On the other end, we can go big. If we do a decameter, for example, or a kilometer, then we're going bigger, and then a megameter would be 10 to the 6 meters. So we have these abbreviations here. Let me change my pen color that we use. So if I was talking about meters, for example, a megameter would be 10 to the 6 meters, while a nanometer, nm, would be 10 to the negative 9 meters. We can put these prefixes or abbreviations in front of anything. So I'm using meters here, but it really could be any type of measurement. We could do liters for this. In chemistry, we commonly will use milliliters and liters, but you could use all sorts of different values as well. So as we get a little bit further along, we're going to be doing unit conversions from one unit to another, but because this is systematic, these are all powers of 10 and they get either bigger or smaller than one another, we're going to be able to do those conversions very nicely and neatly, as opposed to the sort of somewhat arbitrary 16 ounces in a pound, 2,000 pounds in a ton, etc.